Hi, Remy here. Let's see how to install the TMC2208 V2.0 board on the Menta M8P board. To install this, you have two options. One is standalone mode and one is UART mode. For standalone mode, you don't have to do any hardware modification. Just install the driver and set the jumper pins to configure the required microstepping. So to install this, make a note of the orientation. The power connectors on my right side, the header connectors for the driver board is facing towards me, and I have the driver board orientation like this. So you have potentiometer which is facing towards me. To my left you have the black header pins, and my right the blue header pins. So the blue header pin and the red header connectors should go together. They will meet together. You need to install it like this. So the blue and the red will go together. Next, based on the driver board that you have, you need to configure the required microstepping. For that, you need to install few jumpers based on the microstepping required. So you just under the driver board, you have header pins. You have red two rows and black one row. So you need to bridge or put a jumper between the black and the red one. And the last red one, the last row, ignore it. This is to configure in SPI mode. So ignore the bottom row, this row, ignore, and this column, the very first column, you ignore. You need to put jumper on the second column over here between the black and the red, then the next one and the last one. Now these jumpers you need to install based on the microstepping required. Please read the driver board manual on how to configure required jumpers on the M8P board. Now let's see how to install it in UART mode. For that, we need to do a couple of hardware modification. The very first hardware modification, if you look here, there you'll have a resistor over here. Next to that, you'll have an empty shoulder pad. You need to bridge that shoulder pad. And the second modification, you need to bridge the fourth and the fifth pin. So on the blue one, the very first over here, this will be the direction pin, DIR pin. So if this is the first pin, the first, second, third, and fourth. The fourth and the fifth pin should be bridged. Look at the bottom side. You have the DIR pin, and then you have PDN pin, and then the NC pin. So the PDN and the NC pin should be bridged over here. So why this bridging is required? Let's look at the board. So how this board is wired is the fourth pin, 1, 2, 3, and 4. The fourth pin is connected to this red pin over here. And the fifth pin, which is NC, is connected to this pin. The microcontroller talks to this pin. This is, I think, chip select pin. So for UART mode, you need to bridge the chip select pin. So this pin and this pin we need to bridge. But on the board, the UART pin or the PDN pin connects to this pin. So we cannot put a jumper over here diagonal. So from here to here, we cannot put a jumper. That is why we need to bridge the fourth and the fifth pin we need to bridge. Once we do that, we have a connectivity from here to here. So once this is there, we can put a jumper over here, these two pins. Once this is available, then the microcontroller can talk to the driver board in UART mode. Now this modification is for TMC2208. So other drivers, I don't have to test it. Maybe they don't require it. Now let's install the jumpers. So I have installed the jumpers over here. So the very first pin, it's empty. The second one I did a jumper, and the third and the fourth one, they are empty. So you need to remove, if you have a jumper, you need to remove them. Then we can install the drivers. So this one, I need to put a heatsink. doesn't stick, I need to replace this sticky pad. So I have this double-sided adhesive heat transfer tape which I bought from AliExpress. This we need to install. So this is 10 mm in width. And now we can install. So the driver boards are ready. Now let's see in Klipper how to configure this in UART mode. Before we check the Klipper configuration, let's see how we power on the driver boards. So if your main board is powered from here, either with 12 to 24 volts, and if you want your driver boards also to power from the same power source as in the main board, then you need to install jumper pins on VB and VM, that is these two pins, this VM pin and VBB. So you install a jumper on these two pins which are here. So this pin and this pin. So you install a jumper on these two pins. And if you power it using a high voltage, let's say above than 24 volts, 24 like 36, 48 volts, then you install it on these two terminals, negative and positive. In that case, you need to install jumper on HV and VM terminals. That is these two, which are here. This terminal and this terminal. These two terminal, you need to put a jumper. Second thing I forgot to mention, if you are running the stepper driver in standalone mode, you also need to set the current using this potentiometer. So use a multimeter and connect one probe to ground and second probe to this pin, which is VREF. Then adjust the potentiometer to set the desired current. Now let's see Klipper configuration. So log into your printer interface. I use mainsail. Then go to machine and open the default configuration from big tree type. So if you open this, you'll have the sample configuration over here down. So you will see this configuration, which is for TMC2209. It is the same configuration. You only have to change this name to 2208 instead of 2209. So you copy this configuration for the stepper drivers that you are using. So in my case, I'm using for X, X1, Y, and Y1. So I need 4 configuration. So you copy only the configuration that you need. So if you are using for X, then copy only for X configuration, that is just Y, where you are connecting the driver. If the driver is connected to the motor 1 pin on the board, copy this section. If it's connected to motor 3, then copy this section. In my case, I've connected to motor 1, 2, 3, and 4. So I need this configuration. So I'll copy this, which I have already done. I've created a separate file called TMC2208, and this file I have included in the main printer.cfg file over here. So this file I have included here. And let's see this file. So in this file, this is my configuration which I'm using for X, X1, Y, and Y1. Why we need to copy as it is? Because we need the pin configuration. Once you have the pin configuration, you can define the required parameters or change it according to your need. So this is where the configuration changes should be done. So run current when the motor is running, hold current when it is not in motion. Sense resistor 0.1108. This is the default sense resistor on the M8P board. Interpolation is to how to internally multiply the steppers, microstepping. So if I set to, in my configuration, I have set to 16, but internally the driver will convert to 256 microstepping. Stealth chop mode. This, once you have this configuration set over here, save and restart. One important configuration to be noted. Now this configuration is applicable if you are using CAN interface, that is in your printer.cfg file. If your main MCU you have configured using serial, then no change. If you are using CAN bus like I, like I have, then you need to pay attention to have this configuration. Otherwise, you will end up into all sorts of problems to troubleshoot. So this configuration, what I'm showing, is only applicable if your the microcontroller on the Menta M8P board is configured using CAN interface. So the M8P board will have a microcontroller STM and also the option to install either CB1 or the CM4 module. The communication between the CB1 and CM or CM4 with the STM microcontroller can be done using serial or CAN interface. So if serial, then no change. If you have configured CAN, then you have to make sure that you set txqueuelen to 128. Default is something 10. I can't remember exactly. I think it's 10. If you have this default value, if you don't set anything, that means it will take default value, which is 10, and it will have problem using the communication protocol of CAN for buffering. In that case, you need to increase the txqueue length. This is required. Do not miss this to have it if you are using CAN interface. Now let's see if we don't have the txqueue length 128 increase. So if you have the default value of 10, let's see what will happen. I have commented this line and rebooted the operating system. And now we'll go to Klipper printer homepage, and first thing we'll home the printer. So now let's home. So now homing is done. So I will execute this command, that is moving to the back of the corner, X to max and Y to max, and with a very high speed. Now this has failed. The communication has failed. So basically now the MCU has stuck and Klipper is reporting that it cannot communicate. Now next we need to do a restart. And if you look at the Clippy log file, over here, this file, you will have this error. So no buffer space available. And this is documented in Klipper website. So if you go here, it says no buffer. And for that, you have to make sure that txqueuelen you need to increase to 128. So don't forget to increase this if you are using CAN interface. Now let's enable the configuration back. And I'll reboot. Now let's do the same test again after we enable the configuration and the reboot is done. So let's verify the configuration now first. So we have the configuration back in place. Now we'll go to Klipper interface. Let's home the printer. So now homing is done and we'll run the same command again. So now this time the command succeeded and there was no error. So that's all for this video, friends. Do like, share and subscribe. Stay safe and God bless.